Hello, my name is Peter Shapansky. In this video, we'll be going over assignment 1002, medium filter, also known as assignment 20. Okay, so why don't we go ahead and start this main. This will take a while. So as that loads, I will be answering the questions. So first I'll explain how I added the salt and pepper noise to the image and how probably P is used. So in my function called salt and pepper, I start by converting the image into a grayscale version by keeping only the red channels, by taking the third specific column, and that gives me a 2D array of gray intensities. Then I randomly generate a random matrix of numbers, keeping the same shape, using the np.random.rand for gray shape. And as you can see here, here's like the generated output with the original red channel with some noise with P equals 0.05, and then the medium filter W equals 3, and then W equals 9. Then I'll go on and explain what that means later. Okay, and then these are some of the other things, outputs. Okay, so then after I do that, for pixels where R is less than or equal to or less than P divided by 2, I set it to the maximum intensity, which is then white. For pixels where P divided by 2 is less than or equal to R, which is also less than P, I set the value to the maximum intensity, which is the black dots. And then where pixels are greater than or equal to R, I left those unchanged. That way, about a fraction of the P of pixels are turned into salt and pepper, and then P directly controls how noisy the image becomes. Okay, so for 2, my salt and pepper function is loop-free. I don't use every pixel. Instead, I use NumPy's Boolean masks. So then after I create the random matrix, I create 2 masks, the salt mask and the black mask, and then I apply them in one shot. So NumPy applies these assignments to all selected pixels at once, so I never have to need a loop for it. And then this follows the same vectorized style that we use in like the lecture, where we replace loops with arrays, operation for speed, and then cleaner code. Okay, so then how did I apply medium filtering, border handling, and val W values? Okay, so W is where the window size. So inside the function, I treat the input as a 2D array. For each pixel I and j, I want to look at the local W neighborhood around the pixel that replaces the pixel in the medium for each neighborhood. So I compute half of W/2, and then for each pixel I build a row and ranges. So as you can see down here, that's how I do that. Then this is how I handle the pixels near the border. Instead of going outside the image, I clip the window so it always stays within that border. It's centered as much as possible, and then I shrink it whenever it's necessary. In terms of W, the W is expected to be a positive integer, and then my experiment, I used odd values like 3, 5, and 9. So the effect, how does W affect P? So I tested how that affects a small filter like W equals 3 removes some of the salt and pepper noise and still keeps a lot of the fine details you saw earlier. You can still see the remaining noise, but it still looks crisp. And then at 9, it removes a lot more of the noise, and then some of the black-white specks disappear, and it becomes blurrier. So the trade-off is a smaller W is less smoothing, more detail, but more leftover noise. And then larger W is more smoothing, less noise, but more blurring. So as P increases, there are more corrupted pixels, I would say. All right, and that's about it. Thank you.